sure whether polar coordinates. See what I did there? No? Okay. So polar coordinates. So we talked about how you do rectangular coordinates. We've talked about how you do polar coordinates. So what's the connection? So if I have a point that's in one form, how do I get it to okay? Go and then getting it that way. Instead of doing x and y, it's how of the positive x. Does this look a little familiar to you? It should. We've done this sort of thing before with vectors, right? We talk about the direction of a vector. Okay. What is the same thing as magnitude? Look at the picture. R. What's the same thing as direction? Theta. Okay, we're doing the same stuff again. So from x and y. Anyway, well, that's part of the, hold on. So some familiar formulas is going to instead of magnitude but of y over x, just like before. Between things later, but it's the same thing, right? It's just Pythagorean theorem type thing again. If you had a point that was in rectangular form and you wanted to make it polar, magnitude times the cosine of the angle, right? That's what we did. Okay, so I put some points up. There's some of them to get it to be the whatever it's not. See if you can do it. So, give you a few minutes to chew on that. Yeah. Them in polar. These are polar. I would like them in rectangular. What do you mean? Oh, you're talking about just leave it as a decimal. It doesn't necessarily have to have a pi in it. No, we're just used to seeing them that way. Well, yeah, I mean, if it's radians, it's radians. We're just used to seeing radians with pi in the mix, but it's not a necessity though. So it could be like 0.2 radians or whatever, you know. It's fine. If you wanted to put a pi in there, you just take your number and divide it by pi, and it's that much pi. So if you're in love with pi, go for it. But you could. Yeah. I'll go ahead. Two. Give you a hint on the second. Do it. Just think about it. What would be the angle? What would be the radius? You can do that one in your head. So. Right. You see? We're in that neighborhood. Did we all end up getting that one? If it's 0, 5, right? What's the angle up? Yeah.
I had the square root of 15, which is 3.87.
I had the square root of 13.
Yeah.
4 plus 9 is 13. It's all good. Anyway, second one. Straight 5, right? So the angle when you're straight up, pi over 2, right? So the radius should be pi over 2. 4, did everybody recognize that? That's pi over 4. That's on 45-degree angle line, yeah. And square root of 4 squared plus 4 squared is the square root of 32. So if you don't have a calculator, that's all you could do with it, unless you chose to reduce that square root a little bit, but it's fine. So radius is square root 32, 4. So, feeling okay with those? Converting into rectangle, or converting into polar? Okay. I got those. The x2 cosine of pi over 3 gives you 1. 2 sine of pi over 3 is 1.73. Now, the second two, you could still use those two formulas and do it in your head. If you know values, you can do that just fine in your head. 5-0 for the second one. What I did was, again, I tried to think about where it was on the graph and then try to kind of reason it out in my head what that should change to. So like with the first one, I went, okay, I'm going to rotate pi here on the unit circle, but it's -5, so that's pushing it. (5-0). Does that logic make sense, what I just did? Okay, so that you can do it that way too. And in fact, I would do that as a double check even. If you have the time, use the formula to get your answer, but then think about it if you can in that way and see if it ends up in the same place as about where it was supposed to be, and then use that. So if it's a radius of 1 and then it's -3 pi over 2. So -3 pi over 2 would actually be up, right? Opposite of 3 pi over 2, so up at the top of the circle. Radius of 1, so there's no x, but there's 1 in the y, so 0, 1. Just fine on that one, too. Those three. We're okay with those? Those tend to be a little easier to do. Yeah, it's true. Yeah, because you can go of pi, but just switch it negative, right? And that would be the radius the same, you'd have to go a full 2 pi. I do a full rotation, I'm right back to where I started. So if I leave that, would be that new angle. It'd be 9, right? Because you'd have to go 2 pi is 8 pi over 4, right? Up to pi over 4 would be 9. Could go backwards, right? Take away -7. Much as you wanted back and forth, adding 2 pi, subtracting 2 pi. Instead of +2. Well, then you only got to go pi away. You're back the other direction. Example of where you would have -2. One of these where you have to find other ones. If you just sketch it out, it tends to help a little bit too. But get negative and get some more. We've talked about that with trig functions in the past, right? Where you add multiples of whatever. It's positive, you'll get that. All of the polar coordinates that have the same position. Okay, so does that make sense? How to write that out? Very good. To you. Necessarily, but it is a rectangular equation because it just has x and y in it. Can we switch coordinates? Those are going to be key with this stuff too. Substitutions help us here. do is just make it R sin theta. Sometimes that works just great right away, and you can simplify it, and it's all good. To write a polar equation, we do have to solve that for R. Make it R equals something when we're done. And to throw multiple, a little bit challenging to get that thing to simplify. So when you get they're like that being squared. Substitution. What you notice? Yeah, exactly. Solved for R. So you notice though about all three of those terms, we could pull an R out. In fact, since it's equal to 0, we could divide both sides by R and just that one's gone. For R. Think you guys can solve that for R? What would we need to do to get R by itself now? Add those other two terms to the other side, right? Or sign or a combination of the two, it's going to make a circle. More or less makes sense. It's not like a cookie cutter thing. I mean, you're going to have to kind of play around with some of them a little bit. You want to make a substitution of some sort using those equations to help out. Okay? And I will give it will help you. Because I just want to like substitutions. polar equation. Okay, well, let's say that's the one that I want. I want to convert that. I want to know what is the circle in form using x and y instead of r. None of those should work, right?
No.
We've got sine theta, so you're like, oh, look, y maybe, right? But what's wrong with it? It doesn't have an r with it. Right. Do you have a question?
Well, like, what if we move the 2 sine theta over to the other side of the equation, set it up to 0, and then multiply the whole thing by r?
Ooh, you're close. You don't have to do the movement first. He's on it. Kind of like extra multiplication or something like that. Figured it out. Make a substitution, you need an r sine theta. So what do you do to an equation to put an r in there? You could multiply it by r, but whatever you do to one side of an equation, you got to do the same thing to the other, so you'd have to multiply the r by r, giving you r. There you go. For equations, I always want them solved for r, because that's just the way that those are always written. The rectangular, it's not always going to be possible to solve for y. If you can, go for it. One right here, not going to happen, right? Because you got a y squared and a y. You're not going to be able to solve that for y. But then you still have y and the equation in another place, though. This other one. You'd factor out a y, but then you'd still have a left over after you factor out y squared. And you're still kind of stuck with two y's floating around in there. So. little bit as needed and do